of you. Today, my topic of presentation and topic of presentation is Proteus software. I will give you a brief description of a Proteus software, how to use the Proteus software, and the most important, why to use the Proteus software. If there's no, if we don't use Proteus software during any manufacturing or testing of a project, uh, here I have a demonstration. In normal case, this project will take around 4 days, approximately 4 days, to figure the complete working after manufacturing, after assembling the hardware. Because if sometime we assemble the hardware, there are always some hardware issues and software issues also. It is not possible to detect the error is due to which problem, due to software or hardware. So if I use the Proteus software and do all the simulation in the Proteus software, testing the code and basically I test the logical part of the code, testing of codes. Then after that, I need only 1 or 2 iteration to complete the project. Without software, it will take around 50, more than 50 iteration if you do this project by interfacing or by doing practically on the hardware. This project I have developed for some students for for demonstration purpose. This I have completed by tomorrow night. So it take around 1 hour of troubleshooting only. In this project, software used is Proteus. So today I will give you a brief description how to select the components, how to attach circuits before implementing in the real world. Since this is an online course, I will go a little bit slow because of due to lag in the communication. Uh, After installation of the Proteus software, you have to access the Proteus software from the program menu. These are various different files. After installation, the Proteus professional name will appear, and then within this folder you have to select main application file. Proteus it's application file exe file. Then select this this window will open the first time. Okay. You will see old projects which you have previously created, or you can select either new project. Go for the new project option. It will ask the project name, which name you want to save. I, in this application, the first option is name of the file and where you want to save all files on the computer. So in this case, I'm going to save all the files on the desktop. We create a folder name, new folder. rename the folder. So you can see that this is the link of that folder, link address, and you can rename the project. You have to do only the two options. You have to select the name and where to save the files. Next option. Uh, when we create circuit diagram, we have two things. One is schematic. Schematic means the circuit diagram. The circuit diagram that we normally see in the books. That part is known as schematic. So, like in drawings, various engineering drawing softwares, we have a format. Like in engineering drawing, we have a format that write the title of the drawings, date, etc. So similarly, in this case, in circuit designing, we also have some templates. So I'm selecting. You can select the various template size of the templates. So in this case, I'm selecting the A4 size template or A3 size template, and if I if I select do not create schematic, then we are not able to design the schematic, but we can design the PCBs. But, but our requirement is to design the circuit and simulation. So next option is software is asking whether you want to design the PCB of that circuit or not. You simply want to simulate.
Hello, sir. Am I audible?
Yeah.
Excuse me, sir. Excuse me, sir. Am I audible?
Yeah, you are audible.
Sir, your voice is not clear to us. We are unable to understand what you are speaking.
Okay.
So, can you explain this again?
Okay. Now I'm audible.
Your voice not clear.
Hello.
Some echo signal added to your voice, sir.
I'm audible.
So, every center is having the same problem. Your voice is not audible to us.
Some echo signal added to the signal, sir. There is vibration in your voice.
मैम अभी आवाज क्लियर है आपको? हेलो
मैम साउंड के अंदर वाइब्रेशंस आ रही है.
अभी आवाज आ रही है मैम आपको?
Yes, ma'am. आ रही है अब तो. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Starting from the beginning. When you open the Proteus software, you will see this is the startup window. This is the home page. When you first time open the Proteus software, then you have to select the new project. You have to give a name to the project. Here I'm giving it traffic, and you have to select the destination or the path address for the file. So you can select it on any location on the computer. Now, for every drawing, we need some templates or some some size of the drawing sheet according to the size of circuit. So here, in this case, I'm selecting the A3 size of the schematic. Next, what is next? The software is asking whether we want to design the PCB or not design the PCB. Since in our case, we have to only simulate the circuit, we have to test the functionality of circuit, whether it is working or not, whether we have to check the programming. So in this case, we are not going for the PCB designing section. So we have selected do not create PCB layout. And for PCB designing purposes, we generally go for some different softwares. Or this software, Proteus is preferred for generally the schematic testing or the circuit simulation only. For PCB designing, we generally go for the Proteus, Bittrace or CAD, this kind of softwares. So this is an important part. For example, if we want to create some microcontroller based circuit, in such type of circuit, there is a firmware is needed. Some program is needed to be uploaded in the circuit. So the program is known as firmware. Okay, like coding that we have to upload in the circuit, it's known as firmware. Now, you are working, for example, if you are working on a 8051 microcontroller and you are doing the simulation for that. Another thing you parallelly required is you have to write the code for that. But in order to write the code, you need a compiler, external compiler. This Proteus software also have inbuilt compilers. So you don't need to open any external program or software like Keel, Micro C. You don't have to open different compilers. So this Proteus software has inbuilt compilers like C51 compiler, or you can add your own compilers by adding the files into their directories. Okay. So in this case, I'm selecting the create firmware project. In this case, the options available are which family of microcontroller you want to work. There are various families like AVR, 8051, and some miscellaneous like Arduinos. Okay, so depending upon the family of controllers and the which member of family you want to use. Because here the 8051 is a family. Okay, and within this family there are a lot of microcontrollers. Thousands of controllers are available, and based on and from that family which controller you want to use. In our case, we are using 89C5. This is the basic and the beginner microcontrollers for the beginners. The basic microcontroller for beginners and the compiler. See, you can see there are various options are available. It is also displaying some message that which assembler is configured or not configured. In this case, either of compiler is not configured. But these compilers are installed in my computers. So these are picking that compilers option and displaying. We have to connect Keel software with this Proteus software. You can select. This is a compiler section. It's a button for the compiler. You have to select this one, and for example, if you installed a wheel software parallelly, then it will be installed in C directory. Then you have to select just the path of that installation folder and select it here, press OK. Now, your software will be linked with the wheel software. For example, let's see, I have a wheel installed in the C directory files, program files. This is the installation folder. This is the application file. Okay, next option is to finish the project. Okay. When you open the software, you have to select the file name, you have to save the file, you have to select whether you want to make PCB or simply schematic, and whether you want to use the internal compiler of the or assembler of the software or not. But generally, students go for the external compiler because sometimes they use they just directly upload the code to the hardware. In this case, I'm using the external compiler. So this is just for knowledge. Simply you can select the project. These two windows will appear. One window is for the circuit, and another tab is for the. So in this case, this microcontroller will automatically upload it with the hex file that you will write on this side. You don't have to select the path of the hex file. So these both files, hex file and the schematic file, is saved in the desktop folder. What you will write in this source code, it will be saved in your same destination folder that you have selected in the first step. Actually, this software will not have their internal compilers. They will use the compilers installed in your computer. Options. These are the options. Build project, and from here you can generate the hex file. You will follow the standard items. So that will be common and easy to use. This option is rarely used by the students. So, down is simulation purpose first. So I have closed the source code tab. Now we are only left with schematic factor. Since when we have selected the firmware option in during the saving of file, we have selected the 8051 family and the controller. Now software have automatically given a 8051 controller within the drawing file. So this is the drawing format. Like in engineering drawing, we make a box and these indications for the drawings. So these are basic items. These are the basic. Delete this component. We will select our all components again. So the first step in designing schematic is to select the component which you need. So I'm going to design a traffic light controller in which I'm going to use 4 traffic light and 1 microcontroller. 4 traffic light, 1 microcontroller, and the basic circuits required for microcontroller like crystal and some switches. Okay. These are the toolboxes. These are the only toolboxes available in Proteus. And tool available above are the only for cut, copy, paste, zoom. The circuit construction, these are the only available tools. All the functions are inside these tools. For example, this is a component node. You can select the components. This is junction mode. You can create the wiring. You can connect the components. This is for labeling, for example, number of wires you want to label. You can write text. Some script mode, you can write some commands. This is a bus mode. For example, there are a lot of wires you want to use buses. Some circuit code. This is used to create some circuit inside a circuit. Like in C, we use functions. And like in LabVIEW, we have some small sub-functions. Okay. For example, you create this circuit, a big circuit, then you make it a sub-circuit. Then you can use this sub-circuit in another circuit. It will appear like a box only, not complete circuit. And this is a terminal mode. This is a important. We generally require this one. Then we have a ground, power, input and output. Generally, we use ground and power option. And device in option is used when you create your own libraries. For example, you want to use LEDs, diode, and some these components are not available in library. Then what will you do? Then you have to create your own components. You have to create the symbols, you have to assign the pin, you have to assign the voltage rating, then you have to assign the all parameter. Then you can save that file to create a library. You can create your own library, custom library. Then next is graph mode. You can use various functions. This is a function generator mode, for example, AC sweep, DC sweep. Or you can perform Fourier transform or some, you can generate noise, transfer functions, you can generate multiple frequencies. active pop-up mode. This is rarely used for high-end simulations. Generator mode. In this, you have different type of pulse and waveform generators. For debugging the circuit, you want to check the voltage and current at each point of nodes. You can use this probes. This will give you instantaneous value of current at a particular point. Oscilloscope mode. In this, we have some display like oscilloscope logic analyzer for digital circuits, timer counters, virtual terminal for serial. This is used for generally microcontroller. If you are working on a serial communication, then you need some software hyperterminal or some virtual terminal. This software will be good. SPI communication, I2C communication, for example, in microcontroller we deal with real-time clocks, EPROMs. These ICs communicate with I2C and SPI protocols. In order to debug that kind of circuits, we can use these tools. These are very important tool for embedded system. Basic digital AC and voltmeters. And the rest of talks are for making a 2D graphics, for making components, triangle, gear, diode, inductors. First step is to select the, in our case, we have to select the components. We have to click the D button, pick devices. After clicking on component mode, you have to click P. And this option will appear. If you select another section, for example, terminal mode, and you click P, there will be no components. You have to select component mode first and select the P terminal. You have, if you want to learn the different type of component available in markets, then you can use this library also. The components are arranged in very systematic order. For example, LEDs come under optoelectronics. Okay. Diodes, electromechanical have motors, relays, inductors, different. Okay. So the components are arranged in very systematic order. If you know the category in which it lies, you can easily find the components. For example, in microprocessor ICs, we will find the microcontroller. So we have to search. If you select microprocessor ICs, it has further subcategories. Which microprocessor, which family, 8051, and it will display only 8051. Let's try to find components with this method only. If you do search, it will increase your capability to learn the different type of components. So select 89C52. After selecting the component, the main component is this microcontroller. Every component has some parameters or properties that we have to set while simulation. The main property of microcontroller is the operating frequency, the text file it needs. So these are two parameters. So just right click on the component and dialog box will appear. These are the properties for the only 8051 IC. This is a very important parameter, clock frequency. For example, you want to do a real-time simulation. You write a program in a computer to generate a delay of 1 second. Okay. When you write that program in hardware, it will show you 1 second. But if you run that program in Proteus, it will not show you 1 second. Error is due to this frequency. If you select proper frequency that you are using in hardware, then you will get almost same delay that you observe in software. That same delay you will be observing hardware. Almost you get exact replicate of the hardware project. In our case, I have used frequency, and another important parameter is program file. This is a program file. This microcontroller need hex file, so we have to select hex file. Just click on this folder button. In my case, I'm using the key software. The key software, and destination folder for key software is also on the desktop. So we have to select the file that we want to upload in the microcontroller. So only two parameters is frequency and hex file. Uh, in order to understand this circuit, I will give you some simple demonstration of blinking LED. Then I will go for the some big project. Okay. So let's select LEDs. As well, you go for electronics, LEDs, and LEDs available in Proteus is of two types: active and device. It's a symbol of LED. This is a working LED. It will glow the active. So you will see the working of this device. Let's select the red LED. Now this LED also has some properties like forward bias voltage and some unique property like whether you want to model type analog or digital. Actually, this Proteus software will give you only 60 to 70% approximation of your real hardware. But for logical purpose, it will give you more than 99% of your working. For logical, for example, you want to check logical operations, digital operation, it will give you a full output. But for analog purposes, it will not give you the full simulation purposes. Mostly microcontrollers are based on digital, so it will give the best result. So this is the I selected digital LED with forward bias voltage of 2.2. Changing this voltage, you can change the properties, and it will behave like in actual LED. In real life application, we have to install some crystal oscillators, reset circuit, and some external access pins we have to configure. But if you avoid these pins, still it can work. Just upload the program and run the simulation because these are the default parameters. Every IC need ground VCC and basic circuit to work. So this software assumes that these are present. These are by default set in the software. You can see that this IC do not have ground or VCC pin. Software automatically has assigned 5 volt to this. Okay. You can even in some in properties you can see the hidden pins. These are the hidden pins. Let's make a first a simple circuit. Resistance. Rotate the resistance by right click. We need some ground. In order to complete the circuit, we need ground and VCC, but there is no ground and VCC. It pins are hidden, so we have to select the terminal mode and select the ground. If we need power, 21st pin. In the resistance value. You can select any value between 100 to 500 ohms. The next thing required to run this software, this circuit is code. So since this tutorial, this seminar is based on purely Proteus software, so I'm not going to explain much of the key, but I will give you some description. When you open a field software first time, these are the blank section. So the steps to create a project or create a code in a key, these are steps. First you have to select project, new project. So you have to select the destination folder. So project name. Next is you have to select the microcontroller for which you want to write the code. C52. There are some standard codes available with the Seal software. It will give you some standard code, for example codes, for reference purposes. But we don't need that standard, so you go for none. Seal software is configured for assembly. Now we need editor file for writing a text code. Like in a C language, we use text editor and save the file as a .cpp for creating C++ file or C file. In same way, this software, we use text file and we save this text file as a .asm file if you write code in assembly language, or .c if you write in C. Here I am using assembly. .asm. Assembly language is not a case sensitive, so you can use either lowercase or uppercase letter. Now this file is saved as a led.asm. Now you have to add this file to this source. The next step is to write the program. Since in Proteus software, I have connected entity to the port E2.0, so I'm using in the program. And this is a delay function. This program plan is to take the pin 0, wait for a few time, take the pin 1, wait for a few time, and repeat. And this A call is called the function delay. Since there's no libraries are used, I'm taking a delay function. It's a return for the function and this ending of program. After writing the program, you have to compile the program and build the hex file. These are the buttons for completing the file. Now you can see 0 error and 0 warning. Let's see how this program will work on real hardware. We can check with the Proteus. Now we have to upload the hex file. We have created a folder with traffic in. This is the hex file. Let's see the working of circuit without the external crystal or reset circuit. And debug the code. Like circuits, we have also need to check the codes. So these are also debug options. Either code or other circuit. These all need to be tested. If one of thing is wrong, you will not able to see, so you're not able to find the error and you keep on debugging the circuits. So first of all, to check whether code is working or not. You can see that LED is blinking. Now stop this and increase the delay. Make a delay with function with larger delay, or you can do multiple calling. There's no need to upload the file again and again. It will automatically pick and increase. We have seen that no external component is required. These all are resetted in the software. We have not supplied the ground VCC. Let's see working if we remove this VCC. This is external access, whether we want to use internal memory or external memory. In actual hardware, project will not work if we do not connect this pin to the VCC. But in this case, let's check. Circuit is working. Because Proteus assumed that these are, because here we are, Proteus is needed to check the code, not to check the whether person know the circuit or not. So these are the basic requirement. Every microcontroller needs some startup circuit, reset, crystal. So these are basically configured. If you select some ICs, they will not provide the ground and VCC pin. It is assumed that they are connected, and it will also reduce the complexity of circuit. If you connect, then if you connect the circuit, then you don't have to specify in the properties. Rather, do it in command line or connect the components. In our case, the problem statement is to design a traffic light controller, a prototype of traffic light controller with the facilities for the pedestrian movers. If someone wants to cross the lights, they can press the button and traffic light will go green after a few seconds. These facilities are available in different cities or countries in our traffic lights. But in Chandigarh, we don't have this type of facilities for zebra crossing. In this case, there's a buttons available near the zebra crossing. You press the button, you will get the preference for the road crossing. You don't have to wait for the complete time cycle of. So this is a basic demonstration. This. So we need some 4 traffic lights and 4 switches to demonstrate this. So they say now to select the writing a code for this complex application. Since there are 12 outputs, 12 inputs, so it only take a large number of times to debug the code. Okay, but in this case, first of all, I test this circuit on the software. It is working fine. Then code is working fine. Now next task is to make a correct hardware. The program is tested on circuit. If I upload the code to the hardware and that project is not working, so the error is must available only in the hardware. There must be no error in the software because the code is tested. So we have to debug only hardware, and it is easy to debug once we know the target. So after debugging the hardware, the project is ready for testing. So Proteus has some inbuilt traffic light options also. Traffic lights. These are traffic lights. This is the LED, pre-LED, RGB LED, red, yellow, and green. But there's no ground. These are only digital input, high and low. So really add some ground. So it is by default hidden pin. So we have to just connect the ports. We don't have to connect the resistance or some ground combination. Also, we know that zero of microcontroller need a pull-up resistance. Previous program, if I connect the LED to the port 0, and I change the program to port 0, and you'll see that the LED will not work because this port need pull-up resistance. Some pull-up resistance, single pin, connected to VCC. Some portion you can test real time. Traffic lights, 4 traffic lights. Switches. Let's rename this traffic lights as the number 1. Some switches, push button. The active push button. This can be pressed manually. This is active. This is the components are done for the traffic light. Now we have to just do the wiring. Before wiring, we have to match our circuit with the coding. The coding part I have already done. So it's a long coding, so I'm not going to write the code for this. I'm going to explain the code. It's a simple code, right? What is written in assembly language? Since there are a number of same color LEDs, in order to avoid confusion, I have named the traffic lights 1, 2, 3, 4. Okay. So red is 1, green is 1, yellow is 1. Similarly, red 2, red 3, red 4, yellow 1, 2, 3, 4. Okay. Red 1 is connected to E 0.0. Yellow 1 is connected to, increase the font size. Red, first red light. So this is red traffic light 1, traffic light 2, traffic light 3, traffic light 4. Named to the pins using a bit function. Okay. So P 0.0, I have named it as a red 1. In similar way, all LEDs are named with their specific symbol. So this is 1. So red light must be connected to P 0.0. Before that, we need some pull-up resistance. Okay. To select resistance, resistance network. Response network acts before connecting the LEDs to the port 0, we have to connect the resistance to the port 0. We have to give 5 volt to the pull-up resistance. This voltage is required, specific voltage. Connecting the first traffic light, which is E 0.0, 0.1, 0.2. Second traffic light is connected to 0.345. This is second. Port 0 only 2 pins are left unused. Next, next two traffic lights are connected to the port 2. Traffic light, 3 traffic lights are connected. Actual, if you make actual hardware, you need uh, relay drivers, relays, power supplies, and serial communication to test the hardware by uploading the program. But in this case, you don't need these types of hardware. You need only basic logical testing. For example, LEDs for logical testing. Next port will be connected to 2.3. Connection with traffic light is done. Now programming. Now I also need to specify the switch. Switch 1 is for traffic light 1. If somebody press the switch 1, then traffic light 1 will go green. So he can cross the road. Okay. Similarly for traffic light 2, 3, 4 traffic light, 4 switches. These switches are connected to P1.0 and 1.1, 1.3. There is P1.
Excuse me, sir.
Yes.
Sir, your voice is not clear. We are not getting what you are saying.
Now I'm audible.
No, sir.
Sir, actually your voice is breaking continuously.
This may be due to network.
Hello?
This may be due to some network problem.
Hello?
I'm audible. Am I audible?
So your voice is not.
Hello?
Sir, we are unable to understand the voice.
Oh, भाई साहब.
Hello. Am I audible? Yes, YouTube पे देखते हैं.
Hello?
Yes, sir. Am I audible? Am I audible now?
No, ma'am.
Hello. Hello. Are you getting me audible now?
No, ma'am.
Break करा रहे हैं बस. Clear ही नहीं. हो गया?
बहुत बढ़िया, आप देखते हैं क्या है?
वहाँ से.
Hello, now sir, am I audible to you? सर अभी ऑडिबल हूँ?
स्पीकर तो ऑन करो.
Yes, sir.
Yes, sir.
Hello. Hello, now sir, am I audible? Yes, sir. Oh,
Yes,
all
yes.
right, sir. All right, sir.
Loud बोल रहा है.
Uh, am I audible to you?
Yes, sir.
Okay. So we are at we are designing the Proteus circuit, and we are connecting the switches to the microcontroller. So we have connected the 4 traffic lights, pull-up resistance to the microcontroller. Now we are connecting the 4 push buttons, a simple tactical switch or push button to the microcontroller, and this is a common ground to the switches. Now the next part is to, after designing the schematic, is to upload the code. So before uploading the code, I'm going to explain you the code. So these are the 3 bits for the first 3 traffic lights, second traffic light, third traffic light, and fourth. These P1.0 to 1.3 pins is used for the switches. Now after that, assigning and naming these pins, the main code will start. So first of all, we make the all ports 0. This will turn off the all lights. And this is small code written to check whether the program is correctly uploaded or not to the microcontroller. So this is a simple program to blink the LED. So we are just switching on and off a single bit P0.7 with a delay. Now from this side, the first the main traffic light code is started. So here this is a simple logic. We are setting one green and other yellow lights, red and lights to the off condition. So this is a basic like switching on and off the LEDs, but there are a number of LEDs. So we have to take care of logics, and after logic, we have used 3 subroutines, delay subroutine, and between each delay subroutine, the code to scan the switches is used. So after a few seconds, these switches are scanned every time after a few seconds, so that user can input the data to the microcontroller. If you made this code first time, you will find number of errors, and you have to focus only on the code section, programming part. Since there is no hardware part, so you have to totally focus on the software part, and you will get the better output. Just you can parallelly do the testing on this Proteus circuit. So after compiling, let's see the working on this circuit. So first of all, you have to select the code hex file, lb.hex. Okay. Now you can see that first of all, the green light is for traffic light 1. Then after few seconds, this will goes to second, third, fourth, and the complete cycle will follow. Okay. So the delay you are observing in this circuit will be similar to the delay in actual. You can see actual project is also here, and this is a simulation, and you can observe the delay between these. So, we can start both projects at the same time. You can correlate the actual timing on the hardware and software part. Maybe some different old code is used because I have done a lot of iterations. So the next logic is to, if some person want to cross the traffic light 3, then they have to press the switch 3. If they press the switch 3, then for some time all yellow light will blink, and then green will appear on the third light. If you want to again go to the light 1, then you have to press the. So the same function will work here. Here actually I have written the numbers on bulb, but these are exchange. So all are yellow. Then again, one will get the. It is difficult to check this working online, so it's better.
After pressing the button by the visitor, how much time it will take to get it green?
So that depends upon the requirement. So just a prototype.
In this program, which amount of delay is being used?
I have not checked the delay time, but let's see. So this is now this is first one. The green light is on first one, and first. Then the second one is that other side is second one. Okay. Then this is third. First, anti-clockwise. First, second, third, and fourth. Now I want to make the light 4. So this is 4. Now first they will go yellow. Then fourth one will go green. Fourth one will go green. Around 3 or 4 seconds. If you do this troubleshooting directly on the hardware, it will take very long time because the code is also lengthy, the wiring is also complex. If you do systematic work, it will work in the first time. So I have made only 1 or 2 iteration, and that iteration is only in delay, not in the code, logical part, and my project will work in the first attempt. So Proteus is very helpful in designing your project's circuit diagram or for practical application if you want to make the circuits in first attempts without any errors. Okay. Thank you.
Now connector things connect to the different sensors. It has